Assalamu alaikum. Welcome everyone to another video on ETAP software. Actually, we're preparing a series of videos on the ETAP software and different features of ETAP in order to protect the power system and different components of power system. So in our previous videos, we showed you how to protect actually the load using directional overcurrent relay, or also in the normal overcurrent relay. At the same time, we showed you how to protect the generator against fault and how to do the arc flash analysis and so on. So in today's video, we are going to show you a very popular protection scheme used in the power system, which is known as differential relay protection scheme. Okay, differential relay protection. So this differential relay protection is actually used mostly to protect the stator of generator, okay, generator or motor. Sometimes we use to protect the transformer, okay, and also they are used to protect the busbar. So, and actually relay number 87 is the code for the differential relay protection. So in our today's experiment or today's work, actually we'll focus on the protection of transformer and the busbar using ETAP software. And maybe you can remember that this is the power system model we prepared before in one of our previous videos, and we apply different protection schemes on this particular power system. So in this experiment, we are going to protect this transformer T4 with 40 MVA rating. We'll actually apply differential protection for this transformer and this busbar number 3, 140 kV. So before applying the protection scheme, let us very quickly show you the mechanism how a differential relay works. So for example, if you want to protect a transformer like this. So for example, this is a transformer and we want to apply a differential protection. So what should we do? Actually, in order to apply the differential protection, first of all, you need to add 2 CTs in 2 sides of the component you want to protect this way. So this is your CT1 and this is your CT2. And another side are connected like this. So this is actually the relay. Okay, this is nothing but an overcurrent relay. Okay, and the circuit breakers are outside. Over here, one circuit breaker, here is another circuit breaker. Now, there can be 2 scenarios. One scenario is that a fault occurs outside of this protection zone. Actually, when you apply this differential protection, this is actually differential protection scheme, relay number 87 or protection number 87. So it actually protects this transformer in the middle from this point to this point. So if there is any fault in between this location, okay, from this CT1 to CT2, it will consider as an internal fault, and this relay will give the command to this circuit breaker 1 and 2 to trip, okay? But if there is any fault outside, so for example, this is a fault location. So this is an external fault or outside fault. So this relay will not generate any tripping signal, okay? So it will consider as an external fault. So this is actually how a differential relay works, okay? So for an internal fault, I'm just reminding you once again. So this is the internal fault. For an internal fault, this differential relay current will be not equals to 0 and it will trip, okay? But for an external fault, your differential current is equals to 0, so it will not trip. So this is how a differential relay works. So whether you apply for transformer or busbar or a stator winding, so the procedure of operation is same. So let us go to the ETAP software, and we will apply the same mechanism as we have discussed. So first of all, let us apply the protection for this transformer. So if you look at the transformer rating, the current rating primary is 175, secondary is 2099. Okay, based on that, we will select the CT ratios. Okay, so primary was 175. So to match that one, we will give the primary rating 200. Okay, by the way, it should be IEC standard, and select any designation and burden. Okay, so this is our CT1, and the CT2 should be the another side. Sorry. Yes, this is your CT2. If you have noticed that whenever I put the CT2 over here, before it actually toggled its position, now it is fine. So IEC standard, it was how much? 1000. Sorry, how much was the rating? Sorry, I forgot. I think 2099. 2099, yes. So the rating here will be higher than 2099, so 2100. Okay, so it should be IEC standard. Designation is 5P20. 20 volt ampere is the burden. Okay, so I have added the CTs successfully. Okay, now here, before we proceed further, I want to highlight on one particular issue. I just zoomed in just to show you that there are two dots on the CT locations. If you can notice carefully, that this dot is actually indicating the current is leaving away. Okay, so this dot is leaving away. So the one we need to put in the left side of the protected zone. In that CT, your dot should be at the right side. And if the CT is in the right side, then the dot should be in the left side. So for example, if you want to give this CT like this one CT, and you want to protect this one, and this is another CT. So here the dot will be here, and the dot for the second CT should be there. So it means that the current is leaving from this CT and the current is entering into this CT. So if your CT polarity, we call this CT polarity, if the CT polarity is not correct, in that case, it will not work appropriately. Okay, so I hope it is clear. Now, as because the CT has been placed successfully, let us now bring the relay 87. You see, this is our differential relay 87. So I put it here. Now I connect the CTs with the relay. Okay. So this relay 87, it needs some settings, of course. The inputs are the CTs 17 and 19. Okay, so CT 17 and 19. So if you look carefully, this is CT 17, this is CT 19. And the output should be 13 and 15, right? Circuit breaker 13 and 15. So, okay, it should be here. Circuit breaker 13 and 15. Okay, and go to the differential protection, go to library, protection type for the transformer, differential, and ABB manufacturer, and it selects a particular model. Okay, operating time is already selected, so you can press OK. Now this one is done. Here you need to be careful about one more thing, which is actually the rating of the circuit breakers. Okay, because the rating of the circuit breaker is vital here, because you are using this circuit breaker. You want to trip this circuit breaker in this high voltage. It is connected with this high voltage bus. So the circuit breaker rating, if you look carefully, the circuit breaker rating is 4.76 kV only, but it will not be capable of handling the situation if there is a fault. So you need to make it the maximum 121. And also the cycle needs to be 2, because 5 cycle is actually it will provide a long time delay, and that will not allow the circuit breaker to trip appropriately. So the cycle we selected 2, and the maximum kV is the voltage we have maximum in the list, okay, drop down list. So we'll apply the same thing over here in circuit breaker 15. Okay, so I am applying the voltage, and it should be for 2 cycle. Okay, so things are ready now. I hope that everything is so actually it's not saved, the cities, city 17 and 19. Okay, so now we want to apply a fault in between these 2 cities. So that means internal zone. Okay, so if the fault is in between this city 17 and city 19, this should trip the circuit breaker 13 and 15 at the first place. Okay, so let us see. So I have brought this fault, applied it on the transformer. You see this circuit breaker 13 is tripping first, 15 is tripping second, then 6 and 8 are the backup protection. Okay, now if you look carefully the sequence of operation, you will also understand that you see like your relay 5, which is actually your let me see, is 13 and 15. 53 second. At 53 second, they are tripping. And the backup relay 6 and 8, they are tripping at 103 seconds. Milliseconds, sorry. Okay. So which actually fulfills the requirement of the differential protection, because this is what we said, that if there is any fault, occurrence over here, okay, over here, if there is any fault occurrence, this circuit breaker and this circuit breaker should trip. And this is what exactly happening. Now, if we apply an external fault, for example, now we are applying a fault on this line or this bus bar, which is outside of this protection zone. Sorry, it's not applied. So if we apply it here, you will see that these 13 and 15, they are not working. Okay, 13 and 15, they are not working because this is not within the zone. So it will trip the circuit breaker, which will isolate the faulty location from the generator, from the source. So that's why it is tripping circuit breaker number 6 and 8. So I hope it is very clear to all of you that how the differential protection works. So the similar protection mechanism will be applied now on the bus bar. So this bus bar number 3 we will use to apply the protection. So for that, we need to have 3 cities, okay? 3 cities, 1 city in this branch, okay? Second one in this branch, and the third one in this branch, okay? And if you look at the current rating of the cities, actually, sorry, not the current, the bus bar rating, yeah. So what is the current rating for the bus bar? Oh no, it doesn't have any current rating for the bus bar. Let me see. For the transformer, sorry, because the transformer secondary should be the rating of the transformer secondary should be the rating, should match with the rating of the city, right? Because usually in the bus bar rating, we don't have the current rating. Bus bar rating is always voltage, okay? So if you, now we need to see what is the secondary current rating of the transformer, which is connected with this city. So this is actually 131.2, okay? So we need to put the city setting in a way that it will match. By the way, this 1 and 2 two branches are coming actually to this bus. So actually we will apply a bigger value, which will be capable to handle the current for both the branches. So for example, we'll apply 400, okay, because it was 170 or something. So two branches means close to 400. So we can apply 400 ampere, okay. So 5P20, apply here 20 VA. By the way, this ones, if you look at the polarity, is not correct. So we need to rotate this one, okay, inverse polarity. Okay, so I have made it inverse polarity. Okay, so it has been made already. The rating for this city, 400, okay, and 5P20. Burden is 20, okay, and this one's polarity is also needs to be reversed, okay, reverse polarity, because the dot should be in the left side. Okay, so the rating, let's put it 400 and 5P20, and over here 20 volt ampere. Okay, so the cities are ready. Now let's bring the relay number 87 and connect the cities. Relay number 87, with relay number 87, connect the cities. Okay, so they are connected now. So the same setup. For that, the input should be the cities. But how many cities should be the input? 3 cities, right? So, but here the city terminals are selected 2. So you need to make it 3. And whenever you will click, you will find the cities which are connected with the differential relay 20, 21, and 22. Okay. Go to the output, select the circuit breakers. What are the circuit breakers? You should operate 6, 8, and 10. Okay. So first one should be 6, second one should be 8, third one should be 10. Okay. And then go to the differential relay protection scheme, go to library, protection type is bus bar, differential, whatever is the model. Okay, fine. So we have selected everything. I hope. Okay. So actually, this has some problem. Whenever we do it in the first place, it doesn't work. We need to do it twice actually. Okay, I hope it is fine. So let us save the project before we run the simulation and apply the fault. So now let us apply a fault on the bus bar. So this is the bus bar where we want to apply the fault, and it needs to be protected by the differential scheme. So if we apply the fault over here, this should trip circuit breaker 6 first, and then first, second. Okay, this is number 3. And so actually, for some reason, it's not tripping circuit breaker 10. Let me double check. Why is this happening? Maybe because, oh, okay. So CB rating was not determined actually. The cycle should be selected 2. Maximum kV supposed to be higher. Okay. And let us see now. So we apply the fault now here. Okay, so it is tripping first, second, and over here third. Okay, third or fourth, however. But you know, the main issue is that now this bus or this bus bar will be isolated from the power system because of the presence of the fault. Okay, so this is how actually you need to apply the differential protection scheme if you want to protect any bus bar or any transformer or any kind of a stator winding or any winding in your power system. So I hope you understood the experiment and understood the video. So if you have any question, you can put your question in the comment. So thank you very much for listening. Yeah.